Hi everyone, Zach here, and welcome to the final prep video for Section 1. In this video, we will be talking about interfaces, casting, and communicating between different blueprints. And we're doing this in order to understand how we are going to get information from our player, where we have our stats of health, hunger, and stamina, to our widget. This series and this video have been brought to you by Patreon sponsors like Random Number Generator. That said, let's make a start. So, as I've already said in this tutorial, we'll be adding functionality to our UMG, which means we'll be getting information from our player and passing it to our widget. And doing so, we also get to remove those annoying debug print strings from our character. Oh, thank God. So, we need to cover some things we've already talked about, just as a review before we get into the meat of this prep video. We're going to start with encapsulation. So just a brief reminder, encapsulation is like with like. A bird cares about a bird cares about bird functions, a bird cares about singing, flying, pecking at things, nesting, what have you. A tree cares about tree, grow, get taller, grow leaves, photosynthesis, etc., etc. Though in a game, probably photosynthesis isn't such a huge thing unless your game is on being a tree. So, the thing to remember is that they can still communicate with each other. If a bird lands on a tree and we don't want the tree to grow leaves to avoid clipping where that bird is at or where a bird has put a nest, well then there needs to be some communication from the bird going, hey, I've landed here, or hey, I put a nest here, to the tree. And we have a few ways of doing that. We can cast, which you'll often see in tutorials. We can use interfaces, which you'll sometimes see in tutorials, and we can use event dispatchers. Now, you also sometimes see these in tutorials. We're going to avoid event dispatchers because I've been told, and I can't actually find documentation on this, so if you have any, hey, feel free to share it, that event dispatchers are not appropriate in UMG widgets. You can do it, it's just not good practice. So we're going to talk about casting, and we're going to talk about some of the issues with casting before we move on to what we'll be doing, which is the use of interfaces. So, casting. Casting is often done in tutorials. You'll often see it, even in epic-based tutorials. So, hey, they're used a lot. They're good, right? In most cases, casting is not needed and is not the best OOP practice. Wait, if Epic does it, and a lot of tutorials do it, why is it there then if it isn't good? What's going on here? Well, very simply put, it's easier and faster to explain a concept and to show the logic in a tutorial with casting. I've done it. My RTS series, I do a lot of casting. I try to do what I call smart casting, which really doesn't work in blueprints for a number of reasons. We'll get into those. But I try to do it only where it is definitely needed. I only try to do it once. But it's just easier to show stuff. It's easier to explain. It has one less step than doing interfaces. Actually, it's like 2 less steps. But it's just faster. It's just easier. And again, it's cleaner to look at. Now, that said, sometimes casting is the correct choice. And there are particular instances where that comes up. Also, in terms of prototyping or proof of concept or showing how something can be done, where you're not so worried about, how the communication method works, but you're just showing, hey, this is what we're aiming to do, casting is a good placeholder. I will do it myself when I am creating certain tests, even in this series, like our dynamic weather system in Section 5, my test file, the one I use for recording, that one I have on my other screen that I look at, was full of casts, because I just wanted to make sure, hey, that this set of functions is actually accessing that and changing it in this way. I then, after I get the casting version done, I remove the cast and put my interfaces in. If I know the interface is going to work off the bat, or I know the code is going to work off the bat, I skip it. But it just, again, that's more like with the tutorial. It's sometimes just easier to get something on paper, to make it work, and then to clean it up. Remember, coding and scripting and all this stuff is a process of iteration. get the thing working, clean it up. And now this comes to the question, why is it bad? I've already said it's not best OOP practice, but why is casting so bad? And it is a very bad thing, if not done correctly. And that is, it creates hard copies. I'll explain what hard copies is in a few moments. I want to get some other base concepts out so we can understand what a hard copy is. Now, in particular, you need to know that this is more a problem in blueprints than in C++. C++ works a bit differently. And this is due to how blueprints are compiled versus how C++ is compiled. That said, casting is still not the best choice in C++. It is just less terrifying what it does in C++. Not to put fear in anybody by sounding overdramatic with the word terrify there. It creates dependencies, which is a result of this hard copy. It increases file size, which is a direct result of the hard copy. In fact, in, I think, today's video, I show you the file size to make my point. And as I mentioned, it's not best OOP practice. In particular, it violates encapsulation. So suddenly the bird, if it wants to trigger the don't grow leaves here thing, is actually itself telling the tree not to grow the leaves there. It is communicating, but it's getting direct access. It has direct access to all of the functions in that tree and all of the variables. That's not good. That's not good encapsulation. So before we get into hard copies and all the other issues with it, let's talk about some other things. Let's talk about variables again. And this is just a brief reminder that a variable is a container. It contains a particular type of something. So we have variables that contain floats, like our health. And a reminder that the name health has no actual meaning. I could store in actually a great example is my hunger. Hunger is just a very quick way to remind me that this relates to my hunger system. It's actually fullness, really, because the higher the number, the more full the person is. The lower the number, the more starving they are. It is just a way to remember what's being there, or what should be there. Just because it has a particular name doesn't mean that's actually what it's storing. It is a way for us to remember, hey, this is what I'm supposed to be doing this thing. It's a way for us not to have to remember the address in memory. And if you want to learn how to get the address in memory, I have a C++ series that I'm going to return to at some point and complete now that I'm back on YouTube that covers what I mean by that in memory addresses. And just because it is set to a particular class, so if we have a character reference and that's the name of the variable, and it's set to store BP player character, it doesn't mean that variable is actually stored there. It just means it expects to store that information. So I can declare a variable. I can declare a variable, a player reference. I can set that variable type to BP player character. If I do not fill that variable with information, it is just an empty container going, I'm named this, and I'm expecting to store this other thing. And that leads to our read none error. So really quickly, let's talk about this read none error. Read none means a reference variable is empty. Let's talk about this in a logical, non-coding sense for a moment. I have a coffee mug. You just heard me tap it against my desk a couple of times. It's empty, as you can hear. Hint for where we're going with this. I have a coffee mug, therefore I have coffee. Again, it's empty. We can see the logical fallacy in it. Just because I have a coffee mug doesn't mean I have coffee. I finished drinking before I started recording this. So we know that statement isn't true. But saying I have made this variable of player character, well, I should have player character saying the same thing. Wait, it just isn't accurate. You need to put something in it. So we can get rid of that. I have a coffee mug. My mug is the variable. It knows it should store coffee. I have to tell it where to get coffee from. And in real life, I walk down to my coffee machine, put it under the coffee machine, and get my coffee. So there is this entire process of I have a storage container. Now I need to get the thing I store in it and tell it, here you go. And how this works, there's a few different ways of copying data. So in this case, coffee. We're going to really just only talk about one, which is hard copies. But we'll get into that in just a moment. So read none is saying, I know I should have X type. And it's the compiler telling us, but I can't find a particular instance of this type. My coffee mug says to me, hey, you're trying to sip from me, but I'm empty. I'm reading none. I don't have coffee. I know I should have coffee in me, but I don't. What the heck? So when we create a reference variable that is set to say BP player character, it knows what functions player character has because it makes a hard copy. But it doesn't know what instance of player character there is. There could be more than one. So we have to tell it what instance. And that gives kind of our lead in, by the way, to our hard copies. And then this is just a reminder that this is because the variable is just the storage container. So, as I just said, when we make this reference, it knows, hey, these variables exist. These methods and functions exist. I should be able to activate them in this particular instance, but I don't know what this instance is when it's read none. I'm describing read none and a hard copy in one go there. Read none is the end bit. I can't find the instance. The hard copy is that first bit. I know these functions and variables and methods and what have you exist. So let's talk about hard copies. A hard copy loads everything from one class into the class that has made the copy. So, in our UMG widget for a moment, let's imagine that we cast to our player character. Our UMG now is going to load the player character into memory. It is going to have access to all the functions, all the variables, everything that is in our player character class. It will have direct access to. Violation of encapsulation, that last bit. And I hope you caught my wording. Loads into memory. Oh dear God, it loads it into memory. If your player character for some reason is 50 megabytes, by the way, ours is currently 18.8 megabytes of memory serves, that's another 50 megabytes of memory, or in our case 18.8, that you'd end up using. So, the way to think about this, class 1 has a reference to class 2 via casting. Our UMG has a reference to our player character. By the way, we're not doing this, I'm just using this as an example. That means it's loading it every time. Or, let's say class 1 is the player character, and it has a cast to a boss that shows up in level 9. That means in levels 1 through, let's say it's a 10 level game. That means in every level of the game, level 1, 2, 3, 4, 5, 6, 7, 8, where the boss doesn't exist and the player hasn't run into it, the boss is loaded into memory. Let's say then level 9, the boss is there, it's still loaded into memory twice, once for the actual boss instance in the game, and once for the player character. And again in level 10, it gets reloaded. Okay. So we have the potential of having this thing loaded in. Now, take this a step further. The boss references some minions. Now, the player character has a hard copy of the boss. The boss has a hard copy of these minions. The player character has a hard copy of these minions now too, because it's gotten it from the boss, which has a hard copy. Let's say these minions have a hard copy of trigger volumes. Well, so does the player character now. It's inheriting all of these hard copies. So you're loading multiple instances of something. And this happens, as I've pointed out, when the first class making that copy loads. So if it's a player character making a reference to a boss on level 9, it doesn't matter it's level 1 and that boss doesn't exist yet. There's already a hard copy loaded into memory. It doesn't matter the minions in level 9 that boss is making a reference to aren't loaded in yet. Because that reference exists in the boss, it now exists in the player character where we've made the hard copy. And those minions that aren't loaded in yet, well, the triggers that they have a hard copy of, they aren't loaded in yet either, but it doesn't matter, because the triggers are called by the minions are called by the boss is called by the player character. We have a copy of those triggers in every single level now, because that first class, the player character, is calling it. Hopefully you're starting to see why hard copies can be a bad thing and why casting can be a bad thing. Now, to be very clear, casting isn't always bad. There are times we will maybe ourselves making hard copies. We've already done this. Our UMG widget, there's a hard copy loaded into our player character. That's perfectly fine. We want our player character to always have access to the UMG. We do not want the UMG to always have access to the player. Also, that's an interdependency, which is just bad. very, very bad. So, as I've just started to summarize for you, this can eat up a large amount of space and memory. X references Y. Y references Z. Z references A references B. X now has hard copies of Y, Z, A, and B. And as I've talked about, this can create dependencies. And if one of these things bugs out, well, when you delete one of them, well, yeah. There's a beautiful rant on Reddit about this. About, literally, I got the example from the level 9 boss thingy. It is just brilliant. So, hard copies continued. We sometimes need them. Like in our UMG widget, we have a hard copy in our character, and that's fine. But we do not want our UMG widget to have a hard copy of the character. Oh god, that was probably really phrased badly, so I'm going to try that again. We have the UMG widget, which is copied in the character. We have the character, which we do not want copied in the widget. The inventory widget, which we'll do in section 2, and also our equipment widgets in section 3, will actually be making hard copies because we'll have a whole bunch of widget elements. And we want the sort of main inventory and also main equipment widgets to have access to all the sub-widgets. We're kind of operating like a Friends of class approach, which doesn't really exist in Blueprints, but this is the closest we'll get. So again, sometimes we do want these hard copies. Sometimes it makes sense. Sometimes they aren't violating encapsulation because it's like with like still. And there are other instances where hard copies are acceptable. This isn't the end-all be-all list of when hard copies are needed. I am just relating it to what we are doing in this series. So, if casting creates hard copies, and there are other things that create hard copies, like literally just naming a variable, or setting a variable type to be, say, BP player character. Even if we're not loading anything in, it's making a hard copy. Hint for something that's about to come up, by the way. So, if casting is bad, what is our alternative? What are we going to do in this series? We're going to use interfaces. Interfaces are a way for two classes to communicate with each other, especially if they aren't related classes. Per my last example of the UMG widgets, where we have sub-widgets, they're related classes. They can communicate with each other. That's perfectly fine. But our bird and our tree are not related classes. A tree cares about a tree. A bird cares about a bird. That's it. So, a bird lands in a tree. A bird builds a nest. The tree stops growing leaves to avoid clipping in that area. Now, what we can do is the bird builds a nest. It's a function in the bird. This function triggers an interface event. The interface event triggers the function in the tree that tells the tree to stop growing leaves in a particular area. So the way this works is bird to interface, interface to tree. That helps us keep encapsulation. So this is why it's good. It helps us with encapsulation. And sure, it adds an extra step, but as I said, it's cleaner and follows good OOP. Now, let's think about what I just said there. I'm just talking about OOP. I haven't talked about hard copies, right? So interfaces stop hard copies? Oh, God, no. A lot of times I've seen interfaces done, it's actually creating hard copies. It's good use of interfaces that stop hard copies. In fact, I will show you this with our size map in this tutorial video today. And if you want, look at my RTS series. I think it's video 102. I make a rant. And in fact, I actually do a hard copy and an interface in video 102, but I have a rant video called Interface Rants, or 102 Interface Rants, because it ties directly into that video where I talk about how to properly use an interface to stop making hard copies. So in my interface, if I set the return value to be BP player character, or character player, then I am actually making a hard copy via the interface. Whereas if let's say I just want the health, I can create a function that returns a float. And I am going to get that information from the player. If I'm setting it to BP player and then pulling from that and then going, get player health, then I'm essentially casting. That said, what should I do with interfaces? Literally what I just said. You create triggers, we create getters. This is why I've kept saying getters will sometimes be impure, because interfaces are always impure functions. And when you have to access a class, when you have to cast to a particular class, you always want to call the highest possible class possible. That sentence got away from me, clearly. So if you have to access a class setting, you go for the highest, or a method of a particular class. You just need to get the class itself. You always go for the highest class possible. And we will be doing this a lot in sections 2 and 3. Instead of getting our inventory system and casting directly to our inventory system or to the items, we will go to the highest possible actor class. So you might be going, wait, what's this highest possible thing? So I know we haven't talked about inheritance. We will do so in section 2. I can't quite remember where I plan to bring this up. But this is around inheritance. Our character, our BP first-person character, is a class. If you look at the top right corner of the BP file, it says character. That is what we are a child class of. We are that BP player character is a child class of character. Character, if you were to open that up, is a child class of pawn. Pawn is a child class of actor. This actually goes on for quite some time. If you really want to know that entire list, it is actor to pawn, character to pawn, pawn to actor, actor to object, object to object-based utility, and then object base. That's the entire list of inheritance for a player character. Our player character is fairly far down that list. We want to get as high as possible on that list when we use interfaces if we have to get to the class. That's what we'll be doing with actor for our inventory system. So you want to reach the highest possible class in that hierarchy that has the data you need. All right, this has been a 22-minute brief introduction of this topic. Hopefully this has made sense. Sorry if you're hearing me putting the coffee mug down. And that said, we've covered what we need to cover, and we're going to get into our UMG widgets now. That said, I hope you've enjoyed my introduction to interfaces. We will be covering this topic in a lot more depth as we move forward, and about inheritance and putting everything we've been looking at together, especially as we work on our inventory system. If you have, please hit that like button down below. If you want to make sure you're here when we get into talking about our inventory system, make sure to hit the subscribe and notify icon. This series has been brought to you by Patreon sponsors like Haynes, Quad Menson, and Rian. That said, I look forward to seeing you in the final tutorial for section 1 of this series on developing a survival game. And I hope that you have a wonderful day.